Have you ever wondered why New York City is much warmer than its surrounding suburbs? This phenomenon is called the urban heat island. According to the Environmental Protection Agency, on a hot summer day in the city, the pavements and rooftops of buildings can be upwards of 90 degrees warmer than the air temperature because of the absorption of heat on a lower albedo surface.
Now let's look at an example of the equilibrium surface temperature for black pavement at noon during a clear day in New York City, with the air temperature being 90 degrees Fahrenheit and having a wind speed of 5 meters per second. To compute this, you need to solve for the equilibrium surface temperature. As we said earlier, surface temperatures can reach upwards of 90 degrees warmer than the air temperature. On a 90-degree day with a 5 meters per second wind, the surface temperature of a black pavement can be approximately 167 degrees Fahrenheit.
To reduce the urban heat island, many businesses are taking strides in painting rooftops white, as white is a more reflective color. Currently, most of the building rooftops are black, which is the strongest absorber of heat. This is why cities are much warmer than their surrounding suburbs.
To demonstrate how black rooftops are a stronger absorber of heat in comparison to white rooftops, we made two 20 milliliter ice cubes, both with regular tap water, but one with some added black food dye. The black ice cube represents the city as it is today, while the clear ice cube represents the city as it would be with white roofs and white pavements. Both ice cubes were placed under a lamp that was emitting heat. As the time lapse goes through, you will notice that the black ice cube melts faster than the clear ice cube, and this is because of the lower albedo that the black ice cube has compared to the clear ice cube.
Now that you are convinced that a black surface will absorb more heat, resulting in it being hotter, let's take a look at how changing albedo in New York City can affect the amount of heat that the city absorbs. The average solar radiation to come into the city during the middle of a clear summer day is 1,050 watts per meter squared. We will take the solar radiation and multiply it by the difference of the albedo, the white albedo minus the albedo of an urban landscape. If you paint a black surface white, it will absorb 627.9 watts per meter squared less per second. To fully wrap our heads around that number, let's compare it to something many of us in Ithaca are familiar with: a space heater. If you divide 627.9 watts per meter squared by the amount of power required to run a space heater, which is 1500 watts, you are then left with 0.4189 space heaters per meter squared. Let's now compare this value to the area of Manhattan. But first, let's subtract out the area of Central Park from Manhattan's area, because Central Park is actually helping the heat island cool down due to its higher albedo than the typical urban landscape. Now we multiply the amount of space heaters per meter squared by the area, and you get 23.3 million space heaters in Manhattan. This means that if we paint all of the black surfaces white, then we would have 23.3 million space heaters worth of energy being reflected off of the surface rather than being absorbed. Another factor when talking about the urban heat island is the solar noon angle. This is when the sun is at its highest point in the sky each day. We plotted the solar noon angle of 3 major cities in the United States: Miami, Los Angeles, and New York City. You can see that the solar noon angle is the greatest during the summer months, meaning that this is the time where the sun has its peak solar output. Painting surfaces makes a bigger difference for dark surfaces with a higher solar angle. Higher solar angles equal more downward solar radiation, which in turn leads to more energy being absorbed by the surfaces.
With temperatures on the rise, the urban heat island will only be fueled more. Extreme heat is the #1 weather-related cause of death. Painting roofs and surfaces white can reduce the effect of heat absorption in cities, while also lowering AC usage, which will in turn lower energy usage in cities.